I didn't finish yet, so there's a couple more examples I need to I need to show to you guys, okay? I want to show to you that the determinant, how we different way to find a determinant. Okay, so we found a couple ways to find a determinant. We first use the first method. Okay, the first method is expansion. Okay. That's the first method, okay? And the second method, we use the row operation. Now row operation, and then the sum of theorem, we learn like lower zero triangle, okay, and theorems together, like create a lower zero triangle or upper zero triangle like that, right? So so the theorems is about the a few theorems we learn, right? Once create a triangle, once if one row is all zero, that determinant equals zero. So those kind of theorem, okay? Those theorem relate to determinant. So I lower once a triangular, okay? One is the whole row is equal to zero, lower column equals zero, a zero column or row. Okay, and so there's a couple more I think, but these are two we've seen the most. Now you can put these two together to do the problem also. It's not like it has to be just expansion, just this, right? But in the exam I will tell you use expansion or use this one, okay? But in reality you can actually combine them together. Okay, you don't have to just use one or the other. You can actually combine them, so that's good about it. So I found some example, okay? Here's a class example number 1. I will put some class example from now on, so something that the book don't have it. So if I have a matrix A, so here's a matrix. I said find the determinant. Now when you find the determinant, you're going to be, don't write this anymore. This is a matrix notation. Okay, when you find determinant, you gotta take away that notation, okay? Or you can just go determinant A. And you can see that there's a 9 and 3. You can factor out the 3 first, okay? Factor 3 from no 1. Okay, that's it. Okay, no other place you can do that. And then you put a 3 right here. And then you put 3, 1, 0, 0, 3, 1, 0, 0, 3, 9, 2, 2, A, 1, 3, 1. So that's what you get. And then you notice that the first row and the second row are exactly the same. So that means you're going to create a 0. You guys follow me here? So you go, now this is 3. You still have 3 here, okay? Then you go row 1 times by -1 add to row 2. Or you can use one of the theorem. One of the theorem tells you if 2 rows are the same, then it's going to equal 0. But if you want to make sure to get more clear, you can do one more step, okay? Usually when you get to here, you know it's going to be equal to 0. You guys follow me here? Because you have 2 rows exactly the same, okay? But if you want to continue to just to make sure you get it exactly, because this one is the one you remember the most. and then you're gonna get 0. Okay, so this is by the theorem. One of the theorem was that if we have two rows the same equal 0, so you can use that one also. Okay, so if you've seen that, okay, so once you get to here, if some student realize it, these are two exactly same, so that means the determinant is going to equal 0. And you don't even need to do that one, okay? So that's the other method. Is that we use some theorem that we learned. And then the one thing we didn't do is a column operation. So column operation can also give the same result, okay? So here's a class example number 2. If I have a matrix A, okay, and let's try a few different operations, okay, since we get the same result. The first operation I want to use is a row operation. Okay, now in the exam, I'm going to let you know that expansion, you must need to learn how to do it because expansion is still the method people use the most, okay? Although it's a, it's a little bit a longer method, but this method is a little bit more widely used. And then the rest of it, I will give you a choice, okay? You can use a row operation, column operation, or theorem like that, okay? So let's do the row operation first. The row operation means you operate on row, okay? So you look at it, okay, it looks like you could take out the 2 here, that right? That's the same, okay, so you can take out the 2. Okay, and we take out the 2 here. Oh, I forgot to write the direction, sorry. You put down row 1, take out factor 2, okay? So factor 2 from row 1. Okay, and so you have a 2, put a parenthesis there so that we won't, and -2, 1, -1, 1, 0, 1, 3, -1, and 1. So looks like that's all you have. And then let's see. I need to operate on row, so looks like I can take row 2, I can create a lower 0 triangle or upper 0 triangle. That's your goal, okay? Your goal is to create a either lower 0 triangle or upper 0 triangle. Or you can say create an upper triangle or lower triangle. So when they say upper triangle, that means the lower triangle is a 0, okay? So now you can like switch this to 2 row. Hey, sorry about that. Determinant. Okay. So I'm gonna switch this to 2 row first, okay? So I go row 1, switch it for row 2. I took out the 2 before. And then when I switch the row, you have to put a negative sign, okay? Like for determinant, once you switch the row, you need to take out negativity. So I have 1, 0, 1, -2, 1, -1, 3, -1, and 1. Then I'm going to make it 2 to be 0, okay? Now you use the same pivot to do that, then you can do in the same step. I have a -2 here, so I go row 1, times by 2, plus row 2, and then row 1 times by -3 plus row 3. So your row 1 is not changing, so that's the one you use as your operation row, okay? That becomes 0. Times by 2, add to row 1 is add to row 2 is a 1. Times by 2, times by 2, add to here is become 1, okay? times by negative 3 add to here is a 0. Times by 3 add to here is still negative 1. And then times by 3, negative 3 add to here is a negative 2. So when you do this current point, you have to be 100% concentrate, okay? Don't let your mind drift to other place, okay? Train your mind to concentrate on doing these kind of things, and then otherwise you could easily make a mistake here, okay? And because I have that mistake before, so I will never forget when I was in college. You never will forget the mistake you made. Therefore, not being concentrate. So most of the time we drift to place because we are not concentrate. And then we let our thoughts take over our math. So you don't let your thought take over your math. We are doing math and just think math, okay? And now we're going to create 0 here, so we can have a lower 0 triangle, that right? So I'm going to take this one, add to here, so you go row 2, add to row 3. And I still have the negative 2, make sure you put that back in. You add to it, that's a 0. You add to it, that's a negative 1. Okay? And then you create a lower 0 triangle right here, or upper triangle, okay? So how you call it? It's just that my professor called lower 0 triangles. When you first learn from that professor, just stays there. You know, the habit follows. So he will say, look, this is a lower 0 triangle, and then so that's why I use it. It's also called the upper triangle, okay? So if you then take this out, that means the main diagonal multiply is your answer, okay? So you get the main diagonal multiply, so that's equal to negative 2 times the negative 1, so it's equal to 2. So that's by using no operation. Now, if some students cannot use a column operation, you could not. Only for determinant, you are allowed to use a column operation, okay? For Gaussian elimination, you cannot do that, okay? Or for elementary row operation, you cannot. That's why they call elementary row operation, means only operate on row. But for determinant, you have the privilege to operate on column also, okay? So therefore, if your coworker say, hey, let's operate on column, you say, no, we cannot do that. Don't say that, okay? Then they know you didn't learn the material. You could operate on column only for determinant. You guys follow me here? Now this is a special for determinant. So now let's operate on column, see what we get, okay? See if we're going to get the same answer.
Ms. Johnson, real quick.
Yes.
So when you swap the rows, that's when the outside becomes negative?
Yes.
Okay.
Only for determinant I have
Only for
that.
determinant.
Okay, like for Gaussian elimination, you switch it, it doesn't give you that. So that's why determinant is a little bit harder. That's why they have determinant specifically just for whole chapter for determinant, because it's a little bit different, okay? So let's operate on columns, see what we get. So you look at the problems, okay? And maybe I will write the problem. So just maybe I will write the matrix. Okay, my matrix is like this. And this time I'm gonna do a count operation. Actually, the count operation, I look at it, is a little bit easier for this one. Okay, so yeah, column 1, column 2, and column 3. Like this is column 1 here, column 2, and column 3. And we usually go row 1, row 2, row 3, right? So this is the first time we see column 1, column 2, column 3 like that, okay? And then how do we operate this? Determinant A. You look at it looks like if I take the column 3 times by 2, times by negative 2 to go to, oh, you know what, I don't need to. column 3 add to column 2, I could create a 0 here, that right? And then 0 here too, right? Okay, we can do that, okay? And then I take column 3 times by -2, I add to here, I can get 0. I also able to create a lower, upper 0 triangle, a lower triangle. You guys follow me here? If I take this, add to here, this times by -2, add to here, I can have a 0, 0 here. Okay, so that's what I'm going to do. So I'm going to column 1 times by -2 plus a column, columns 3 times by -2 plus column 1. Columns 3 times by -2 add to column 1, okay? And then columns 3 add to column 2. It's a determinant, so don't write matrix, okay? And you can see here when I times by -2 add to here, I get 0. -2 add to here, I get -1. Okay? -2 add to here, I get 1. Right? And then column 3 add to column 2, I get 0. Add to here's 1. Add to here's a 0. And then I get -2, 1, 1. I'm pretty close now. I still need to make what? It looks like I should
Lower 0 triangle. Well, you have a 0.
if I switch this to 2, if I can add this column, you can have a column and all these these two add together, then I can make this with 0, but then this one won't be 0 anymore.
You switch 1 and 3.
Switch it. No. If I can take out -2 here, right? Take out -2. So I can take out -2 here. What else I can do? I need to create either lower 0 triangle or upper 0 triangle. So if I create -2, but if you take out -2, that doesn't make anything. This one to switch. No. I look at what I did. Oh, okay. After that, I use expansion. You could combine, remember I mentioned that? You could combine any method together. So it looks like I couldn't do anything anymore, then I use expansion, okay? So I use the column operation first and then I use expansion. So I'm using this one. Expand it, okay? You could, now, you can, all the method I teach you, it can combine them together, okay? It's not like you can only use one or the other, okay? A lot of time I look at it, people use a row operation, then expansion, okay? Or column operation and expansion, I forgot. We can add them together. So I go plus, minus, and plus. So I expand the -2. -1, 1, 1, 0. Okay, and that becomes -2 times by 0 minus 1. Again, you get 2. Okay, so that's the other way to do the problem. And so this way is faster. Okay, you didn't create a lower 0 triangle. You're not able to. Then, if you're not able to, then you're gonna just go ahead and do the expansion for the rest of it. And the last one is I think that. Yeah, so that's it. Okay, so this is a column expansion. Okay, a column operation plus expansion. Okay. So in the exam, one problem you can only use a pure expansion, and then another is up to you how you're going to operate it. Okay. So I want you guys to understand all this method can work, okay? And all that combined. So that's for the rest of 2.2, and now we're gonna start do the application application determinant 2.3.